Hello, hi everyone, and welcome. I am 𝐒𝐞𝐫𝐵 a senior CPU design verification engineer at Synopsys. So previously, I am working in Synopsys here for over 1 year, 1 year, 1 month, and before this, I have worked in Intel for more than 2 years. Before that, I did my MTech from IIT Kanpur with very good grades. Okay, yeah. So okay, today we will continue our uh, studying or walkthrough of the HDLBits problem solving, and we will be starting wherever we ended last in the last video. And yeah, basically try these problems first. As always, do not watch this video before trying. Start the you know do the problems first yourself, and uh, whenever you are stuck or you are confused how to approach this problem, come back to this video. Or if you want to know my approach, how I solved it, come back to this video and check how I solved it. Okay, it will give you a good idea how to solve these kind of circuits. Okay, yeah, let's start. So I'm planning this to be a big 3-hour video if possible. We will be covering a lot of questions here. It uh, it will not be a small one. Okay, so okay, uh, let's start. Okay, great. Okay, so in the last class, we covered this modules and vectors where we had these three D flip-flops, and then we were supposed to give clock to all of those flip-flops, and these three should have separate outputs, these three flip-flops, and we will give all of them to a mux, and through the select line we will select which output to take to this output. Okay, which flip-flop output to give it to the Q output. Okay, so okay, let's go to the next problem. So it says module add. Here we are given a module add 16 that performs a 16-bit addition. Instantiate two of them to create a 32-bit adder. Okay, we are given a module add 16, so it adds 16 bits of A and 16 bits of B to form a 16-bit sum and 1-bit carry. So this is the adder. Okay, 16-bit adder. It performs a 16-bit addition. Instantiate two of them to create a 32-bit adder. Okay, so we need two of these to create a 32-bit adder. One add 16 module, one add 16 module computes the lower 16 bits of the addition result. Okay, one of them computes the lower 16 bits, so this one, while the second add 16 module computes the upper 16 bits of the result after receiving the carry out from the first adder. After receiving the carry out from the first adder. Okay, the 32-bit adder does not need to handle carry in. The first adder does not need to handle carry in because in this case the carry in is by default 0, because let's say we don't give any carry in. Okay, or carry out ignored. So it's saying that assume carry in is 0 and carry out is ignored. Carry out is probably this one. It's saying that ignore it, but the internal modules need to be in order to function correctly. In other words, add 16 module performs as 16-bit A plus B plus C in, while your module performs 32-bit A plus B. 32-bit A plus B. So there is no C in, and there will be a C out, but they are probably not using it. This is the 16-bit. C out is not used. They are worrying only about the sum, not the carry out. So what I will do is I'll create a wire C out, okay, and a wire C out internal. Okay, C out internal is this one. C out to next scene. Okay, and this C out external. But I'll say let's do like this. Let's create. Okay, two. Two means, or let's say two. Two means it will have like 0 and 1. Okay, C out 0, C out 1. So I'll treat this as C out 0. This is C out 1. And this will be C in. Or carry, let's say 0, 1, 2. Carry, I'll do it carry. Carry 3. Okay. And what I'll do is I'll instantiate 2 of these. Okay. I'll instantiate 2 of these. So add 16 adder 1, where we have input, which is A, and here it's like 15 down to 0. We are giving here A 15 down to 0. And then we have B, $15 down to 0. Input, we don't have anything. Okay, but we will say carry of 0 equal to 0. Okay, or let's say we don't need to give this. We will say carry 2 down to 1. Okay, we will not do 1 up to 2. Okay, because this is array. Okay, here we will not give carry in, we will give 0. Okay, or let's say no, 1 tick B is 0. Okay, and here output sum, what we will do is we will say we will need, we don't need anything actually, because sum is directly fed to the output. So we will have 15 up to 0, sum 15 up to 0, and output will be this carry of 1. Okay, this carry of 1 is the output of this A1 adder. Okay, and what we will do is we will copy this and paste. Okay, and we name this as A2, where we have here 15. So this will be 31 down to 16. 31 down to 16. And here we will have carry of 1 connected here. And then we will have carry of 2 connected here. Okay. Just try to make things a bit, look like. Okay. Okay. Okay, that should be enough because we are getting the sum. We are having carry, but we are not using this carry anywhere. So we are not giving this carry. Okay. Let's submit. I think we did a mistake. Okay, we didn't give 0. We gave 0 directly here. Okay, if I did 0 here, then we need to do it within initial begin. I forgot. I thought I wrote something carry something equal to 0. But yeah, if we don't write 0, I mean, if I want to give a variable name here, carry of 1 or something, carry of 0, and if I want to define it here, then we have to do it within initial begin. But because we didn't do that, so things are working great. Okay, so it says you solved 25 problems. Anyways, this is the input it gave, and this is my output, and this is the reference output. Okay, so this is the reference output. Okay, so let's move on to the next problem. Adder 2. In this exercise, we'll create a circuit with 2 levels of hierarchy. Your top module will instantiate 2 copies of add16 provided, each of which will instantiate 16 copies of. In this exercise, we will create a circuit with 2 levels of hierarchy. So the circuit will have 2 hierarchies basically. So it's like inside top module you have add16, and inside add16 you have multiple add1s. Okay, and you have 2 such add16s. Okay, you will create a circuit with 2 levels of hierarchy. Your top module will instantiate 2 copies of add16 which is provided, each of which will instantiate 16 copies of add1 which you must write. That is what we need to write here. This also we need to write now. Actually, with using add16, 2 of those add16s we created the top module. Now they are saying, okay, now implement the add16 and also implement the add1. Everything we need to implement. This is the add1 and implement the add16. Okay, or add. I guess add16 how it should look they have given. Let me see what they're asking. Like module add, you are given a module add16 that performs a 16-bit addition. You must instantiate 2 of them to create a 32-bit adder. You must instantiate 2 of them to create a 32-bit adder. One add16 module computes the lower 16 bits of the addition result, while the second 16 module computes the upper 16 bits of the result. Your 32-bit adder does not need to handle carry in or carry out. Given a module add 16, thus you must write two modules, the top module and add one. We don't need to write the add 16. Add 16 is written. We have to write the top module and the add one. Okay. How to implement the add one and how to implement the top module. Like module add, you are given a add 16 that performs 16-bit addition. You must instantiate two of them to create a 32-bit adder. One computes the lower and the second computes the upper. Your 32-bit adder does not need to handle carry in. Your 32-bit adder does not need to handle carry in, 0 or carry out. Your 32-bit adder does not need to handle carry in or carry out. Okay. Like the last one only. Connect the add 16 modules together as shown. Okay. So you have to connect the add 16 modules like this. It's the same thing. With each add 16, 16 full adders are instantiated to actually perform the addition. You must write full adder module that has the following declaration. This is the add one. Recall the full adder computes carry. Okay. In summary, there are three modules to the design. Top module, top level module that contains two of add 16 provided. A 16-bit adder module that is composed of 16. Add one, a 1-bit full adder module. Okay, if your submission is missing a module, add one. Okay, you'll get error message. Okay, 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 good. So what we need to do is first we need to create the full adder code here. So let's delete all of this first. Okay. So we have input A, input B, seen. So we will say sum equal to A XOR B XOR Cin. Okay. And we will say carry C out. We should be very careful about the variables used. C out equal to A XOR B. Sorry. A XOR B. It's like A or B and Cin or A and B. Okay. So this is the before this write assign. Okay. So sum becomes A XOR B XOR Cin. Carry out becomes A XOR B. So it's like A and B, both of them are 1. Then carry out is 1. Or if A is 1, B is 0, or A 0, B is 1, and C is 1. So that means either A1, C1 or B1, C1. Okay. So what we have written is basically A and B, or B and C in, or A and C in. So that is what actually we have implemented. Okay. If I just say okay, we have implemented actually this in a shorter form. So we can write this, we can write this, anything is fine. Okay. So this is the like 1 bit full adder, and what we need to write here is basically the same thing. Okay. So this is given to us. This is given to us. We will use this the same way we did last time. I'll just move this here because add 16 a 16 1. Okay. I'll just say this, this, yeah. So here we will write 1 tick B0, and here we will say carry of 1. Okay. So yeah, so we created 2 wires as carry. So this is the first wire which is connecting to here, and this is the second wire, randomly dangling wire. We are not giving it to the output, and we are giving here A 15 down to 0, B 15 down to 0, sum 15 down to 0, and the carry input is 0. And here we have 31 down to 16, A, B, and sum. We have this carry 1. The output of first adder carry out is connected to the carry in of the second one, and this is the carry out of the second one, which is not connected anywhere. And A, B, and sum are the outputs, final outputs, A, B, and sum. That is what we did. Here we had the assign statements, which is the 1 bit thing. And okay, I guess we can submit. Unless and until we did some spelling mistake or something. We should not get an error. Yeah, the status is success as usual, as expected. Okay, so you got to understand, right? We here actually we are given the top module. This is the top module where two 16-bit adders are already given. Two 16-bit adders are already given, but within the 16-bit adders we have some 1-bit adders as well, the implementation of which we needed to do here in this case. Okay, and here if I just interchange this one with this one, then also nothing will change. I mean, it will remain the same. If you just do the k map and solve it normally, you will see this is the thing that gets generated. Okay, for carry, we just create the table. So a, b, c in carry sum. If we just calculate the carry, you will see it's like a and b. If a and b both are 1, or b and c both are 1, or a and c both are 1, in that case this will be the output. Okay, yeah, let's go to the next problem. Yeah, so module carry select adder. Okay, so here what we are doing is we are giving this 15 down to 0. Okay, this is the initial bits. So carry in is 0. Okay, and considering carry as 1, we are generating two uh, outputs basically. Okay, so the upper 16 bits are given to two full adders, to 16-bit full adders. So based on whatever is the carry out, we select whether we need to select this carry in as 0 or this carry in as 1, because that carry out should be the carry in. So what happens is we kind of do this addition parallelly and then take the output uh, directly. Okay, so that's a very good way. uh, okay, let me see. So we have to create another sum bits and carry in 0, carry in 1, internal carry ins, or we don't need, actually we can just give the values. Okay, so what we will do is we will say add 16. A16. Okay, so this is the first one. Okay, I'll say for 0, let's say this is the 0th adder, and first instance of this because we don't need two of them. Okay. This will be 1 1 and 1 2. This will be 31 down to 16. So what happens is here it's like 0 1 out of 1. So 0 means this is the first one, and after this for 1 we have like 2 of the choices, out of which we will select one of them. Okay, so 1 1 and 1 2. Or let's say we will name them as 1 1 2 1 2 2. Okay, for no lower segment we have here also we can do 0. That's the best convention. For 0th word or half word, we are giving this. We have only one option, so 0 0. And for first half word, we are giving like two options, so it's like 0 0 and 0 1. Like 1 0 and 1 1 basically. Okay, and here we are saying this is okay. Here also we are giving a, b, and sum, the same thing. It's not sum actually. Here it will be s uh, 0. Here we will give s1. Okay, so we will have to write a wire s, and we will write 31 down to 16. Okay, s, and this s has 0 up to 1. Okay, these are the two possible arrays, and here we will have carry. Wire carry. Sum is already there. we will select based on this carry out. This carry first to the first we will give carry equal to 0 and carry out will be 1, carry of 1. We'll say wire carry of and then we will have two carry outs, basically this one and this one, which are redundant. So let's say we will give the name carry. This is the output carry. And here we will give the name C0 C1. Okay. This is carry based on which this will be selected, and this is just C0 C1. And here we will have one tick B0, one tick B1 as inputs. Sum 0 is like 31 down to 16. So 131 down to 16. Any of these will be output. And based on carry, sum 31 down to 16 is equal to, or I'll say assign this equal to the value. The value is carry. If carry is 1, sum of 0, okay, or sorry, sum of 1 or sum of 0. Okay. Sum is 31 down to 16 only. I can just eliminate here sum of 0. Okay. I think we are to go. We'll say carry 0 colon 1. So we have wired this and wire carry and wire C 0 colon 1. And here we are giving one tick B0, one tick B1, and sum of 0, sum of 1. We're not giving from where to where because it's like 31 down to 16. We give everything of that vector. Assign sum of 31 down to 16 as the carry. If carry is 1, we take sum 1 as output, otherwise we take sum 0. Yeah, it's done. So we didn't do any spelling mistake or something, it should be correct. Yeah, success. Okay. So I hope you understood this issue, this problem. Okay. Now we have a module add sub. What we will do here is we will do addition and subtraction at the same time. An adder subtractor can be built from an adder by optionally negating one of the inputs, which is equivalent to inverting the input when adding one. When inverting the input and then adding one. Okay. So if sub equal to 1, we are inverting the input using XOR. It's like 0 XOR B is B, 1 XOR B is B bar. Okay. And then when sub is 1, we are giving 1 here and also adding that value to C in. Okay. Okay. It's like if sub equal to 0, we give B to here. Otherwise, if sub equal to 1, we give B bar to this. Okay. So what is given? It's add 16, which is given. Okay. We are not giving, but sub is given. Okay. Good. Add 16. We will say wire. And we will say this B is the issue. So what we will give is 31 down to 0. B intermediate. Okay. Intermediate or B not intermediate, B modified. Okay. B modified. It's a one variable, 32-bit variable. Okay. I'll say assign B modified equal to sub. If sub is 1, then B modified equal to complement of B, otherwise B. Okay. So it's like if sub equal to 1, then B mod gets the negative complement of B, otherwise it gets B. Okay. Okay. So we have A. Now we will not have here B. We will have here B mod, and here as an input carry we will have sub. Okay, this sub value. So we will give here sub, and then this cout carry, we will say this is carry, and this is also carry. Carry of 0, carry of 1. We will say wire 0 up to 1. We will say output is carry of 0. Okay, and we'll give it a name A16 1. Turn down to 16. P mod 31 down to 16. This is carry. Actually, this should be 1. Here it should be 1. Here it should be 2. 1 colon 2. We are changing the naming convention of the carry. We are saying carry 1, carry of 1, same output is connected to the next input, and give 31 down to 16, carry of 2. Yeah, basically we are done. So what we are doing is we are saying, okay, this is the sub. Here I gave carry input as sub. Output is sum 31 down to 16, 15 down to 0. Here we have A. Here we have B. Okay, B and B mod. Here this output is connected here. We are giving sub as input. Carry 2, which is not connected anywhere. But we are getting the sum. We are giving the sub. A and B also we are getting. Carry be defined. And B mod is basically subtraction is 1. If yes, do negation of B, otherwise keep B. We are good to go. So let's submit. Okay, great. We got success. Okay, so we'll be covering these procedures in the next video. Okay, let's end the stream here. And yeah, wanted to mention a few more things quickly. That okay, like we solved these problems. Okay, check these first, and if you have solved it differently, or if you have any other solution in mind, if you have a better approach, to like please drop it in the comments. I would love to see your approach and how you solved it, and like if you have any doubts, put that also in the comments. I will reply in the comments. And if you have more doubts or something that I need time to describe or something, we can describe it in the in a separate video. Okay, and till then keep practicing, and I'll see you in the next video with these procedures. Okay, okay, bye, have a great day.